Have you ever wondered how electricity flows in different types of circuits? Well, you're not alone. Today, we're going to unravel the mysteries of electrical circuits, specifically focusing on series and parallel types. But first, let's define what an electrical circuit is. An electrical circuit, in its simplest form, is a closed loop that allows electric current to flow from one point to another. Imagine it like a racetrack where electricity, or the race cars, can speed around as long as the track is complete. But if there's a break in the circuit or a gap in the track, the electricity can't flow. In this video, we will delve into the world of series and parallel circuits, exploring how they operate and how we can analyze them. We'll learn about their unique features, their differences, and their practical applications. So, are you ready to explore how electricity travels in these circuits? Great. Let's dive in. First on our list is the series circuit, but what exactly is it? Well, imagine a single road stretching from point A to point B. That's essentially what a series circuit is. It's a single pathway for electric current to flow from one end to the other. Similar to how a car can't just jump off the road and create a new path, in a series circuit, the current has only one route to take. This means that the current flowing through each component in the series is the same. It doesn't matter if you have one light bulb or 10, the same current will flow through them all. However, this simplicity comes with a notable catch. Let's say you have a string of Christmas lights set up as a series circuit. If one bulb burns out, the entire string of lights will go out. Why? Because when one bulb goes out, it breaks the single path of the circuit. The circuit becomes open, and the current can no longer flow, leaving you in the dark. This characteristic is a crucial aspect of series circuits. It may seem like a disadvantage, but it's actually very useful in certain applications, such as in a string of Christmas lights, where it's easier to identify a single faulty bulb when the whole string goes out. In essence, a series circuit is like a marathon race where everyone follows one single path, and if one stops, everyone behind them stops too. Now, that's a series circuit broken down for you. Next up, we have parallel circuits, but how do they differ from series circuits? In the world of electricity, parallel circuits are like the social butterflies. Unlike their series counterparts, where electricity has only one path to follow, parallel circuits offer multiple paths. Picture a bustling city with a network of roads and intersections. That's essentially a parallel circuit in action. Now let's imagine these paths as conduits for our electrical current. In a parallel circuit, each device connected to the circuit has its own separate path for the electricity to flow through. This unique characteristic gives parallel circuits a bit of an edge. Think about a string of Christmas lights. If one bulb blows out, it can be quite a chore to find the culprit in a series circuit. But in a parallel circuit, it's no problem at all. Why? Because each bulb, or in our case, each device, operates independently. If one bulb goes out, the others will still stay lit. The electricity simply bypasses the faulty bulb and continues on its merry way along the other paths. So, in essence, a parallel circuit is like a city's road network. It's designed with efficiency in mind. Each device has its own route, ensuring that the overall system keeps running smoothly, even when a single component fails. So, a parallel circuit is like a multi-lane highway, where even if one lane is blocked, traffic can still flow through the other lanes. Alright, now that we've explored both series and parallel circuits, let's recap what we've learned. We've delved into the unique world of electrical circuits, beginning with series circuits, where current flows through one path only. We've seen how the total resistance in a series circuit is simply the sum of individual resistances. Then we hopped over to parallel circuits where current divides into multiple paths. We learned that the total resistance in a parallel circuit is a bit more complex to calculate, but it's always less than the smallest resistance in the circuit. We've also highlighted the differences between the two. In series circuits, a break anywhere disrupts the entire circuit. While in parallel circuits, other paths continue to function even if one path breaks. Remember, understanding circuits is not only essential for electricians or engineers, but it's also a fun and fascinating part of our everyday lives. So, keep exploring, keep learning, and keep the curiosity alive.